Good afternoon. Let me introduce report on topic methods of pilot's flight technique model building based on statistical data. Authors are Maxim Zalitsky, Yuri Hryshchenko, Viktor Romanenko, Yulia Petrova, Vladislav Hryshchenko. My name is Yuri Hryshchenko. The presented research is devoted by the problem of the influence of the human factor on the safety of the aircraft in civil aviation. It analyzes the pilot's flight style, which characterizes the individual characteristics of aircraft piloting. The technical operation of aircraft, one of the cases, is to ensure the safety of the flights. Currently, special attention is paid to issues related to the influence of the human factor in the safety of aircraft flights. Scientific papers highlight to the tasks of the influence of the human factor on flight safety at various stages of an aircraft flight. In these works, the concept of the pilot error can be divided into categories. The first category is mistake made by the pilot as a result of inadequate assessment of abnormal flight situation or as a result of the pilot's high psychophysiological tension or in difficult aircraft flight conditions. The second category is errors as a direct error, which is made by the pilot due to the individual characteristic as well as because of the temporary worsened psycho-emotional or physical condition. That is an error of the second category, is an error without influence or external causal link. In order to significantly reduce the risk of pilot error of this category, it is necessary to periodically carry out anti-stress training on simulator or specific type of aircraft both or for an individual pilot and training him as a part of the crew. The flight style of pilot is a technique of the piloting of an aircraft which is characterized by its individual characteristics. In the presented research, the monitoring of flight style is carried out using developed mathematical model. It is based on the Kruskal values statistical test. It allows a comparative analysis of medians of several samples. The Kruskal values criterion on the multidimensional and rank are widely used in psychology and other fields of science. Thus, the main goal of the this paper is to study the pilot's flight style under normal aircraft flight conditions using a specially developed mathematical model based on Kruskal values statistical criteria. The translation data of aircraft Boeing 737 flight information was obtained from the airline for the analysis of flight style. To do this, the seconds of real flights were taken after approaching the glide path until landing. The landing approach took place at different airports, so the length of the glide path and accordingly the amount of data differ. To analyze the flight information data, the pitch amplitudes in the above flight segments were taken. Let's consider the methods of building a model of a pilot's flight style on a concrete example of statistical data. You can see table data for 4 flights and same pilots. And so the total amount of the variation is equal of sum from 1 to 4, sum k sub 1 that is equal to 306, and the table 2 you can see statistical characteristic of the data. The visual view of implementation of the study data is shown in figure number 1. The second step of calculation is determine the total ranks of each data separately, that is, calculate the corresponding values according for the formulas. And you can see these formulas and this equation. The sample under the study contains repeated values. The major data contains 48 duplicate values with a repetition range from 2 to 24. A primary analysis of the combined data provides the following estimates of statistical characteristics. The distribution histogram for the combined data and the theoretical probability density function are shown in figure number 1. To make a final decretion, Pearson's chi-square goodness of fit test applied. The calculation gives the value of parameter chi-square equal 8.885. It follows from above that it is necessary to create a Denke bank of flight styles using the flight parameters based both on simulators and on real flights. And you can see it is in figure in this scheme, a scheme of the data bank of the flight style using flight parameters. Conclusion: the paper is developed on the solution of scientific important safety problem of ensuring flight safety related to the human factor in terms of improving piloting style in cases of aircraft equipment failure, worsening weather conditions and features of the location of the airfield. The paper discussed the issue substantiating the possibility of combining measured data arrays for various stressful situations. The result of statistical data process showed that when we perform this flight under normal flight conditions, the pilot's flying style does not change. The generalized statistical model of the pilot's flight style that does not contradict the normal distribution law. The obtained result of the statistical analysis of the data of the pilot's flight style makes it possible to develop a method of continuous monitoring of the pilot flight during the flight in order to reduce risk of the pilot error for the second category. Based on the research is following made. It is necessary to collect data of each pilot in various stressful situations. The ability to match data must be checked based in Kraskov-Ellis test. Thank you for your attention.